Welcome to the Duck Dive. This is where we take complex ideas and, well, try to extract the most important nuggets of knowledge for you. Today, we're diving into something pretty fundamental in software, foundational domain modeling. Specifically, how you build systems that are robust and extensible right from the ground up.
So you know how in programming, pretty much every object, it ultimately goes back to something super general, right? Like java.lang.Object. It feels a bit like trying to build, I don't know, a sophisticated car starting just with raw iron ore.
Right, it's just too broad, too undifferentiated.
Exactly. And our source material suggests that can lead to code becoming brittle, maybe hard to follow, prone to runtime errors.
Yeah, as systems get bigger, definitely. While java.lang.Object is foundational, like you said, it really dilutes the meaning, the semantics of what your specific domain object is actually supposed to represent. It's like every building block is just this generic blob.
A blob, yeah. What's really interesting here and what the source gets into is designing a more specialized, yet still kind of universal building block, but within your specific problem space. Think of it like defining electrons and protons before you even get to atoms. They're not just generic stuff. They have properties, identity.
Okay, I like that analogy. Electrons and protons.
Precisely. That's what we want for our software entities.
And that's where the central idea comes in, right? This foundational concept called the base object.
Exactly.
So this deep dive, we're going to unpack how this seemingly simple idea, but with this clever self-referential thing going on, how it rigorously enforces some really powerful design principles. And the payoff is, well, surprisingly robust and flexible software. It gives everything its own clear identity, basically.
From day one. It avoids a lot of headaches down the line, like type confusion or endless casting.
Okay, so let's get into this base object then. Our source calls it the ultimate supertype for domain entities, like an artist or maybe a label in some data system. But it's not just a placeholder, and this is where I think it gets really interesting. It's declared as base K extends base.
Yeah, that looks a bit technical, maybe.
It does, but the idea is like base is saying, okay, I'm a foundation, and whatever builds on me, that's the K. It also has to be a kind of foundation.
It's a recursive definition, exactly.
Wow.
A self-referential contract. It ensures K will always be the specific concrete type that's actually implementing base.
Right.
And crucially, base also implements this interface, KongSupplier K. Sounds fancy, but it's actually deceptive in its simplicity.
KongSupplier K.
All it really has is a get method.
Yeah.
And that get method just returns
It returns itself.
It returns itself the instant. It's like this little I am statement built into every single base object. The object intrinsically knows its own true concrete type and can just hand it over safely.
Okay. So with that structure, how does this help with those core design principles? Let's start with SRP, the single responsibility principle. You know, a class should only have one reason to change.
Right. For base, its single, very profound responsibility is defining the fundamental essence, the self-identity, of a domain object instance. That KongSupplier K interface with its get method returning this, that directly embodies this I am one idea.
I am one, like the number one in math.
Exactly like the number one. It just is itself a fundamental unit within its domain. Unlike java.lang.Object, which is totally generic, base introduces domain meaning, but crucially, without getting bogged down in business logic or how it gets saved or anything like that.
Ah, okay. So its only reason to change would be if the very definition of what it means to be a fundamental entity in this domain changed.
Precisely. It's purely about self-identity.
Is it common, though, for people to be tempted to, like, sneak other stuff into a base class like this? Utilities, maybe?
Oh, absolutely. That's a constant temptation. You might think, oh, let's add a save method here or validate.
It was convenient.
It might seem convenient, but this design, because it's so laser-focused on identity through that KongSupplier's get, it kind of makes adding unrelated things feel, well, wrong, jarring. It strongly encourages you, almost forces you, to keep base pure and push those other responsibilities like saving or validation into separate services or maybe more specialized subclasses. So it naturally reinforces SRP.
I see. So the purity of its purpose-defining self pushes other concerns away. Makes sense. Okay, what about the Liskov Substitution Principle, LSP? This one's always a bit trickier, being able to swap a subclass for a superclass without anything breaking.
LSP can be subtle, but here the K extends base constraint, and that KongSupplier K interface are absolutely central to enforcing it. Think about it. When some method expects a base, maybe just any base object,
right,
and it calls that get method, It's absolutely guaranteed by the type system to receive an instance of the actual concrete type of that object.
Guaranteed at compile time, not runtime.
Guaranteed to compile time. So imagine you have a list that holds base objects. Maybe there's an artist in there and a label.
Oh, right.
You can loop through that list, call get, on each element, and you reliably get back the artist object or the label object. They maintain their unique self-identity perfectly.
So no need for risky casting or instance of checks to figure out what you really have.
Exactly. It ensures polymorphic consistency, type safety, and it means you can add new types, like maybe a genre type later, without breaking any existing code that just works with base. It makes the system super extensible.
That is powerful. It avoids those runtime type checks that can become messy and error-prone, especially in big systems.
Totally. It provides that direct, type-safe way to always get the concrete instance. It's a compile time guarantee of type integrity.
It feels like this design, by nailing down identity so strongly, it kind of naturally supports other solid principles too. Like you mentioned extensibility. That sounds like the open-closed principle. Open for extension, closed for modification.
Absolutely spot on. It's a fantastic consequence, perhaps even an intentional outcome, of getting this foundation right. By encapsulating that core identity in base and KongSupplier, you can easily add new specialized types, new classes that extend base without ever needing to touch or modify the original base definition itself.
Or the code that just deals with base, generally.
The code that deals with base, it remains stable. That's the open-close principle in action. You extend by adding new base subtypes, but the core remains closed to modification.
So wrapping this up, what does this really mean for you, the listener, maybe grappling with complex systems? This deep dive into base seems to show how really thoughtful foundational design and getting those electrons and protons right, not just starting with the raw iron ore, it creates systems that are just much more robust, easier to maintain, and easier to extend later on.
Indeed. By really nailing down that fundamental essence and self-identity of every core domain object, this kind of architecture doesn't just stabilize things like, say, data processing pipelines. It really provides a powerful blueprint for building almost any complex system that needs to be type-safe and highly extensible.
It really makes you think, doesn't it, about how critical those early fundamental architectural choices are. So as you look at systems, maybe consider what are their fundamental building blocks, those self-identifying units, and how well do they actually uphold their core responsibilities?
How pure is their identity?
Exactly. Something to ponder maybe until our next deep dive.